Okay, good morning everyone. Today we'll take a look at multiplying polynomials. We'll learn how to multiply polynomials. You've done a little bit of this before, but we'll be multiplying higher degree polynomials today. So the first method we'll use in multiplying polynomials is the distributive method. So let's take a look at the distributive method. So here I have two polynomials, x plus 2 has degree 1. And then x squared plus 4x minus 3, it's degree 2. So when I multiply x plus 2 times x squared plus 4x minus 3, I use the distributive method. I distribute, so notice here in the red lines, I distribute the x to the x squared. So x times x squared is x cubed. X times 4x is 4x squared, and x times negative 3 is negative 3x. And then I distribute the 2 to the x squared, so 2 times x squared is 2x squared, and 2 times 4x is 8x, and then 2 times negative 3 is negative 6. And then we combine our like terms vertically. So I have x cubed, and then 4 plus 2 is 6, so 6x squared, and negative 3 plus 8 is 5, so 5x, and then minus 6. So before multiplying, I had what was called the factor form, and then after multiplying, I have what's called the standard form. Now, one way you could check your work is you can graph both the factor form and standard form on Desmos, and if you do everything right, the graphs should overlap. So let's take a look. All right, so here you see I graphed, so that was the, so that was the factor form, x plus 2 times x squared plus 4x minus 3, x plus 2 times x squared plus 4x minus 3, and then I graph the standard form. So the first one was the factored form, the second one is the standard form. X cubed plus 6x squared plus 5x minus 6. X cubed plus 6x squared plus 5x minus 6. And as you can see, the two graphs, they overlap, which means that I did everything correctly. Good way to check your work. Okay, so notice I have a third degree polynomial. I knew that before I multiplied. 1 plus 2 is 3, so I get a third degree polynomial. Leading coefficient is 1. Okay, as a third degree polynomial with a positive leading coefficient, the end behavior as x goes to positive infinity, y goes to positive infinity. As x goes to negative infinity, y goes to negative infinity. My domain for polynomials, always all real numbers. And then the range for odd degree polynomials is to always all real numbers, because the ends, that one goes to positive infinity and that goes to negative infinity. So all real numbers. And then I notice I have a local maximum here and a local minimum here. All right, local max and local min. I have no global max or global min. You never have a global max or global min for an odd degree polynomial. Let's look at some more. So here I have three factors, x minus 1 times x plus 2 times x plus 3. So I need to multiply all three factors. The first thing I'll do is I'll multiply x plus 2 times x plus 3. Remember to FOIL. FOIL is like using the distributive method. So x times x is x squared, x times 3 is 3x, and 2 times x is 2x, and 2 times 3 is 6. Combine the like terms and you get x squared plus 5x plus 6. And then I'll multiply x minus 1. So x times x squared is x cubed, x times 5x is 5x squared, x times 6 is 6x, and then negative 1 times x squared is negative x squared, negative 1 times 5x is negative 5x, and negative 1 times 6 is negative 6. When I combine my like terms, I get x cubed, 5 minus 1 is 4, so 4x squared, 6 minus 5 is 1x, and then minus 6. So I have the factor form and the standard form. It's a third degree polynomial. The degree of that factor is 1, 1, and 1, but I can see that in any n, when I multiply, I have a third degree polynomial. Just to check to make sure I did everything okay, I will graph both the factor form and the standard form on decimals. Let me take off those graphs. So there was the factor form x minus 1 times x plus 2 times x plus 3. And then x cubed plus 4x squared plus 6 minus x. So notice they overlap. My multiplication was done correctly. Okay, the end behavior. It's an odd degree polynomial as x goes to positive infinity, y goes to positive infinity. And as x goes to negative infinity, y goes to negative infinity. Again, as before, the domain of all polynomials is all real numbers. You can use any x. And the range for odd degree polynomials, again, is always all real numbers. The ends, they go to positive and negative infinity. And here I have a local max and a local min. And as always with odd degree polynomials, you have no global max or global min. Okay, let's look at another one. So here I have 4 factors, x plus 3, x plus 1, x minus 2, and x minus 1. The degree of each factor is 1. So I should have a fourth degree polynomial. In order to multiply this, I have to multiply x minus 1 times x minus 2 first. So I'm going to FOIL that first. And when I FOIL and combine my like terms, I'll get x squared minus 3x plus 2. And then I'll FOIL x plus 3 times x plus 1. When I FOIL and combine my like terms, I get x squared plus 4x plus 3. So here I am going to use the box method. You could use the distributive method. I like the box method when I have like trinomials I'm multiplying. So what I do is I make a 3 by 3 box. On the top here, I write the polynomial x squared, 4x, and 3. And on the sides here, I'll write x squared minus 3x and 2. And then I just multiply each box. X squared times x squared is x to the 4th. X squared times 4x is 4x cubed. And then x squared times 3 is 3x squared. And then negative 3x times x squared is negative 3x cubed. Negative 3x times 4x is negative 12x squared. And then negative 3x times 3 is negative 9x. 2 times x squared is 2x squared. 2 times 4x is 8x. And 2 times 3 is 6. I've completed my box. So now what we do is we add on the diagonals. We combine our like terms on the diagonals here. So when I combine, I get x to the 4th, and then negative 3 plus 4 gives me 1x cubed, and then 12x squared minus 12x squared, or 2x squared minus 12x squared. Well, that would be negative 10x squared, and then plus 3x squared would give me a negative 7x squared. And then 8x minus 9x would give me negative x, and then I have 6. So now I have the standard form. I started with the factor form and the standard form, and as you can see, I have a 4th degree polynomial. Leading coefficient is 1. Alright, so let me verify my multiplication. I'll go out to decimals, and I'll graph both the factored form and the standard form. So let me turn these graphs off. So there was the factored form there, and then there was the standard form. They overlap. So I did my work correctly. Okay, so in behavior, this is even degree polynomial. Remember, the ends, they go in the same direction. So as x goes to positive infinity, y goes to positive infinity. As x goes to negative infinity, y goes to positive infinity. The domain, again, for all polynomials, is all real numbers. I can use any x value in my function. The range, though, well, it's going to reach a global minimum right there. So this will be a global minimum. The smallest y value on that graph. Let's check what that is with Schoology. I mean Desmos. All right, so I'm going to zoom in here. And the smallest y value I have looks to be about negative 12.949. Negative 12.949. So my range is going to be y is greater than or equal to negative 12.949. Here I have so that is a local min. And here I have a local max. I have a local maximum. I have no global maximum. The ends, they go on to infinity, positive infinity. But I do have a global minimum. With even degree polynomials, you will have either a global minimum or a global maximum, even degree. Odd degree, you never have it, global min or global max. And then the last one we'll take a look at is x squared plus 5x plus 6 and x minus 1 times x plus 2. I actually could have written x squared plus 5x plus 6 as x plus 2 times x plus 3 factors of 6 that add up to 5 is 2 and 3. Okay, but to make this shorter, I just wrote x squared plus 5x plus 6 times x minus 1 times x plus 2. When I FOIL x minus 1 times x plus 2, I get x squared plus x minus 2. And then I'll multiply that by x squared plus 5x plus 6. So again, I write x squared plus 5x plus 6. I make my box. I'm using the box method. Again, I'm using the box method here. And then I write x squared and 5x and 6 on the top, and then x squared and x and minus 2 on the sides, and I just multiply each box. So I get x to the fourth. X squared times 5x is 5x cubed. X squared times 6 is 6x squared. X times x squared is x cubed. X times 5x is 5x squared, and x times 6 is 6x. Negative 2 times x squared is negative 2x squared. Negative 2 times 5x is negative 10x. And then negative 2 times 6 is negative 12. And again, I add on the diagonals. So I have x to the fourth. 1 plus 5 is 6, so 6x cubed. And then negative 2 plus 5 plus 6, that will give me 9. So I'll have 9x squared. And then negative 10 and 6 gives me negative 4. So negative 4x and then minus 12. So I have my standard form. Standard form. And when I graph that on Desmos, okay, so both graphs agree, so I did my work okay. It's a fourth degree polynomial, even degree, positive leading coefficient. So as x goes to positive infinity, y goes to positive infinity. And as x goes to negative infinity, y goes to positive infinity. I see a local minimum there and a local max. The domain, again, for every polynomial is always all real numbers. But I need to find my range. Okay, so I'll use Desmos to find the smallest y value I have. Right, so and that's that graph there, x to the fourth plus 6x cubed plus 9x squared minus 4x minus 12. Let me just check. Yep, x to the fourth plus 6x cubed plus 9x squared minus 4x minus 12. And if I zoom out, you'll see the graph. It looks like that. But then I need to zoom in to get the smallest y value. And that's about negative 12.393. Okay, so the range is going to be y is greater than or equal to negative 12.393. That's my global minimum. Global minimum there. Okay, so that was today's lesson. Graphing polynomials, or multiplying polynomials, and checking your work using both the standard form and the factor form to make sure the two graphs agree, and then going over properties of polynomials like we did yesterday.